This video is going to demonstrate how to proceed with the determination of a molar mass of an unknown compound by the freezing point depression. As we are most familiar with, the freezing point depression is when a solute is dissolved in a solvent and the freezing point of the solution is lower than the pure solvent. Much like the example that in wintertime where we put salt on ice and snow, that we lower the freezing point of the snow or the ice to more or less the lowest temperature that we achieve in the region. For example, water freezes at 0, and by putting enough salt we can lower that freezing point to -10 to -15, and being water, then it could either drive off to the gutters or they'll dry up and do that. So we'll walk through the procedure using lauric acid as our solvent, and you'll be given an unknown to determine the molar mass. Precision and accuracy will be marked in this lab as we know what the unknown molar mass is, and therefore your purpose is to become close as possible to the true molar mass of the unknown solute. What we'll be using is the Pasco equipment that most of you are familiar with from the gas laws for Chem 110. We'll have the notebook, and we'll have the connection for a thermometer that will register the temperature continuously as the lauric acid or the lauric acid solution freezes, and where the graph plateaus will be our freezing point of the pure lauric acid and the lauric acid solution, and from that we will be able to determine delta TF, the absolute difference between the two freezing points. As you recall, we turn on the computer first, and we make sure that that's booted up and running before we connect the Pasco unit with the USB. As you can see, here is the Pasco unit with the thermometer, different than the equipment that you use, the 110 for the gas law. So while that computer is loading up, we will weigh the empty test tube and then put lauric acid in it, determine how much lauric acid we have as our solvent, and we will show you how to make the jacket for the thermos-like insulator so that it doesn't cool down too quickly. Okay, so in order to make the jacket, you'll need a second test tube, and we'll use a paper towel. Just rip the paper towel in half, and then in half again, and then fold that, roll it around the mouth of the small test tube, and then insert it into the larger test tube, so that keeps the inner test tube from touching the outer, and you'll have a little air jacket in between so that the small test tube doesn't cool down as quickly. And you can set that aside, and then we will go and weigh the empty glassware to determine how much lauric acid we have. So as usual, you're familiar with weighing and substances, so turn on the balance. So you've obtained a beaker and the smaller inner test tube. So we'll record that mass of empty glassware. Remember to record all digits, even if the last couple are zeros. And now we'll return to the lab, placing some lauric acid into the glassware, and then coming back and weighing the glassware and the lauric acid. So this will be the lauric acid, or the duodeconic acid. It'll be located on the side benches, as most specialized chemicals for each lab are located. So obtain your small test tube and carefully place about 3/4 of the test tube of lauric acid. It's not critical how much you put in, it's critical that you weigh it. So put about that much, so maybe that's 5/8. Okay. So we'll take that back, weigh that, and then we'll do the subtraction to find out how much lauric acid that we have, that we need to know the amount of lauric acid, because freezing point depression is dependent on the molality of the solution, which is moles of solute over kilograms of solvent. So now we bring back our glassware with our lauric acid. Place that here. And then you'll do the subtraction to get the mass of lauric acid that you're using, in order that you can use it in the freezing point depression calculation. Okay, so now that the computer is started up, I can connect the Pasco USB connector so that the application starts up. And while the application starts up, we can put the lauric acid in the hot water so that it'll melt, and then we'll record the freezing curve by the thermometer from the Pasco units. See that the lauric acid has started to melt, and I could begin with the thermometer, giving it a little stir so it melts a little bit quicker. So you want to raise the temperature of the melted lauric acid to about 60 or so degrees, because the higher the temperature, then the longer it's going to take to freeze. So you can push start, and we see that it's already at 44 degrees. And it's starting to melt, so that must be close to the melting freezing point. Right now we're at 50 degrees. So as soon as it's reached about 60 degrees, you'll be removing it from the hot water, drying off the small test tube, and then we'll put it into the jacket and just keep stirring it. It's all melted right now. And then we're almost there at 55-ish. Maybe I'll just leave it alone, let it get to 60. There we go. So now it's reached 60, so we'll be able to take it out of the water, and we'll dry the smaller test tube, and we'll put it into the cooling jacket. Okay. And so now I'm going to be stirring it, and the temperature will be coming down. And I'm going to continuously stir this until the temperature stays constant for 3 to 5 minutes. So we're going to be here for a while. It's coming down, continuously stirring it so that the heat and the cooling is uniform. So we're going to see what the plateau. So can't really see it yet. Oh, there. You can see the slush starting to form. and it's at 43.5. So if I stir it properly, it will never get solid freezing. I'll just, the energy of stirring will melt and some will freeze. At some point in time, I won't be able to overcome the coolness, but you can see that it's at 43.5 and it's been there for about a minute and a half. So I'm going to continue to stir it. And it's still at 43.5. So another 30 seconds have gone by. It's still at 43.5. If you were to look in the textbook, you'd probably find that the freezing point of lauric acid is around 42. But we're concerned more about the change in the freezing point rather than the absolute freezing point. So this could be a function of the purity of the lauric acid, a thermometer calibration. So the important thing is that we keep it steady for a good few minutes so that we know what the freezing point is to begin with. And then, as I mentioned, we're just concerned about how much lower it's going to be because of the equation is delta TF. The change in freezing point is equal to a constant times the molality of the solution. So you can see the coolness is starting to take over, but I seem to keep it at 43.5. And we'll probably go another minute so that we get a good graph and a good plateau so that we get a good indication of delta TF. So it appears that from the point that I started recording the temperature, it's going to come up to 15 minutes is when I'm going to stop it. I think we've collected enough data. And we're almost home stretch. And then when it reaches the time, I'm just going to click stop on the computer. And we're almost there. Just going to take it out of the jacket. And we're going to put it back into the water because we want it melted for when we add our unknown. Okay. So what we can do now is take a look at the graph to show you. So we'll be clicking on the graph in the lower part of the left-hand screen. And we'll click on temperature run number 1. Right there is the plateau of the 43.5 that we'll be using as our freezing point of pure lauric acid. So now we'll be taking our unknown, recording the unknown number, and then we'll put it into the melted lauric acid, and it already has. So that's nice. So we'll just turn it off. Okay. So we'll go weigh the vial with it, pour it into the test tube, and then weigh the vial empty, and we'll know how much unknown we have put into the solution. We have our vial with our unknown. We've recorded the unknown number, and we record that. And now we'll return to the lab, empty the vial into the liquid pure lauric acid, and then come back and mask the empty vial to determine how much unknown we've put into the solvent.
Go again.
So we have the lauric acid that's been melted. And we have our unknown. Do your best. It's got to be an easy way. Okay. some stuck on the sides. Try to get it all into intimate contact with the lauric acid. Maybe the heat will let it slide down. We'll go weigh the vial so that we know how much unknown we have entered into the test tube into the lauric acid. So we have our empty vial. We're going to record the amount. And then we'll do our subtraction to determine the amount of unknown that is in with the pure lauric acid. Okay, we have put the unknown in the melted lauric acid. And we'll put this smaller test tube into the cooling jacket. And we will start the computer. And we will do the same technique. We'll keep stirring it until we get a constant temperature. And according to the science, the freezing point of the solution should be lower than the freezing point of the pure lauric acid, which in this case was 43.5. So we'll also be looking for the slush point as to when we first see the solution freezing up. So we're just approaching the freezing point of the lauric acid. We'll just keep stirring and we'll try to notice the slush point. So looks like the science is coming true. We have no slush and we're at 43.5. Down to 42.8. No apparent slush yet. So the freezing point depression is dependent upon how much lauric acid I had and how much unknown I've put in. To fulfill the equation, delta TF equals to KF times molality. Down to 41.1, and no slush yet. Well, we are down below the freezing point of pure lauric acid, so our hypothesis and the science is coming true. So we're at 41.5 and no indication of slush yet. So the amount that the freezing point gets depressed is equal to the constant of lauric acid times the molality of the solution. May be tedious, but it's a neat experiment, people. I guess the question is, can we raise the melting or the freezing point? And I guess talking about freezing point depression tells us we can't go freezing point elevation. We're down to 39.7. Lauric acid is one of the main ingredients in coconut oil. So we have some slush here at 36.7, 36.8. So we'll see, keep that constant. That's the plateau. And it's 1 minute's passed at that temperature, 36.9. 2 minutes. It's just gone down a bit at 36.8, but so we've done, this is the solution. We're going to look at the graph of the freezing point of the solution. And here it's not quite as nice and flat, but there's the plateau for the freezing point of the solution. And we determined that to be, what was it, 36.9 or so. So here's an example of the chart that you would be preparing for the lab on your two-part form. So you put a heading, the glass, the mass of the different equipment that you need, the freezing point. So I could go ahead and fill it out for you here. So the empty glassware was at 28.95 with the lauric acid, 33 grams, and the freezing point of pure lauric acid was 43.5 degrees, and our unknown was. So our freezing point depression would be the subtraction of those two. So there's 6.6 degrees. Our mass of unknown number, that you'll fill in when you come, obviously, on the day of the lab. And the empty vial was 1344.5. And then the mass of unknown that was put into the lauric acid, what's the difference of those two? And then you would use all the data. See if I can do the math backwards. I hope that's correct. And then you would rearrange the equation so that you can get the molar mass, Kf, out of the lab manual. What's that? So you'll be doing this calculation for molar mass after you obtain all your data, and you will be doing the calculation in class before you leave the lab, so that you'll leave with a correct and an accurate answer.